Think backing up servers in Azure is complicated? It's actually a lot easier than many would think. In this video, we'll explore Azure Backup, how it works, what it protects, and why it's one of the most important services for protecting your Azure environment. Hello everyone, I'm Travis and welcome back to the channel. About 6 years ago, I created some content on Azure Backup, and those videos generated a lot of interest. But Azure has evolved significantly since then, and so has Azure Backup. In this video, we're taking a fresh look at Azure Backup. We'll start with an architecture and service overview, cover the key concepts you need to understand, and then jump into a hands-on demo where we'll back up an Azure VM. Before we get started, please like, subscribe, and share the video. It really helps the channel grow, and I appreciate the support. If you're looking for more Azure training, be sure to check out my courses. The links are below. And thanks to all my channel members, your support is appreciated. All right, let's jump in. And a fair warning, there's a lot of information coming your way because having a solid understanding of the Azure Backup service is important to designing reliable and resilient cloud environments. So what exactly is Azure Backup? Azure Backup is part of a larger collection of services grouped under Azure Resiliency. Azure Resiliency provides a unified experience for protecting and managing workloads across Azure and hybrid environments. Azure Backup is often mentioned alongside Azure Site Recovery because they share some underlying technologies, but they're designed for different purposes. Azure Backup is focused on recovering data from the past. That could mean restoring a single file, recovering a database, or bringing back an entire server from a previous point in time. Azure Site Recovery, on the other hand, is focused on disaster recovery. Its goal is to bring systems online quickly in another location using the most current data possible. Historical recovery points aren't relevant with Azure Site Recovery. Azure Backup can protect a wide variety of Azure resources and on-premises workloads. Within Azure, it supports services such as Azure Virtual Machines, Managed Disks, Azure Blobs, Azure Files, multiple types of database services, Azure Kubernetes Services, and Azure Elastic SAN. For on-premises environments, Azure Backup can protect VMs, files and folders, system state data, Hyper-V, VMware, and other supported workloads in your data center. One of the best features is how backups work for Azure native resources. In most cases, you don't need to install a backup agent. For Azure Virtual Machines, Azure Backup uses a snapshot management extension that coordinates the volume shadow copy service, or VSS, to create application-consistent backups. For many other Azure services, backup functionality is integrated directly into the Azure control plane. For on-premises systems, Microsoft provides the Microsoft Azure Recovery Services agent, commonly known as the MARS agent. This agent is installed on protected systems and sends backup data directly to Azure Backup. There are also enterprise backup solutions such as System-Centered Data Protection Manager, or DPM, and Microsoft Azure Backup Server, also known as MABS. MABS is based on DPM and provides similar functionality without requiring a System Center license. Both solutions are primarily focused on local backup infrastructure and won't be covered in this video. Like most Azure services, access to Azure Backup is controlled using Azure Role-Based Access Control, or RBAC. There are 3 built-in backup roles. Backup Contributor can manage nearly all backup operations except deleting vaults and managing access permissions. Backup Operator has similar capabilities but can't delete backups or modify backup policies. And Backup Reader provides read-only access to backup settings and information. Azure Backup also plays an important role in ransomware protection strategies. Of course, any backup solution can help recover from ransomware attacks, but Azure Backup includes additional protections specifically designed to defend backup data. Backup data is stored in Azure Managed Storage, where attackers don't have direct access to the underlying storage accounts, and data can be encrypted using Microsoft Managed Keys or Customer Managed Keys. Soft Delete helps protect against accidental or malicious deletion by retaining backup data for a limited period of time once it's deleted. Azure Backup also supports immutable vaults, which can prevent backup data from being modified or removed. And built-in monitoring and alerting provides visibility into backup-related events and potential security concerns. So where does all this backup data go? Azure provides 2 vault options, the Recovery Services Vault and the Backup Vault. Both are used to store and manage backup data, but there are a couple important differences. A Recovery Services Vault can be used with both Azure Backup and Azure Site Recovery. A Backup Vault is designed exclusively for Azure Backup workloads. The vault type you select is largely determined by the workload you're protecting. Recovery Services Vaults support Azure Virtual Machines, SQL servers running on Azure VMs, Azure Files, SAP HANA on Azure VMs, Azure Backup Server, the Azure Backup Agent, and DPM. If you're protecting any of those workloads, you'll need a Recovery Services Vault. Backup Vault supports Azure Disks, Azure Blobs, Azure Database for PostgreSQL, and Kubernetes workloads. Regardless of which vault type you use, Azure provides 3 storage redundancy options, including local redundant storage, geo-redundant storage, and zone redundant storage. Azure Backup also provides different storage tiers, including snapshots, standard, and archive tier. The available tier options depends on the workload being protected. Now that we know what can be protected and where the backup data is stored, let's talk about how Azure Backup actually performs those backups. Let's start with backup policies. Backup policies define how and when resources are protected. They determine backup schedules, retention settings, storage configuration, and recovery point management. There are 2 policy types, standard and enhanced. Standard policies provide a limited set of features. They support fewer scheduling options, shorter snapshot retention periods, only support locally redundant storage, and don't support newer virtual machine technologies such as Trusted Launch and UltraDisks. Enhance expands on those options, and in most environments, enhanced policies are the preferred choice. And if you're already using standard policies, Microsoft provides a way to move them to enhanced policies. The key advantage to backup policies is scalability. Instead of managing backup settings individually for each resource, you can assign a policy and manage everything centrally. If backup requirements change, updating the policy updates protection settings across all associated resources. Backup policies also define how recovery points are created. Azure Backup supports full backups and incremental backups. Incremental backups only capture data that's changed since the previous backup, reducing storage consumption and improving efficiency. Differential backups, on the other hand, captures all changes since the last full backup. Because the same changes can be included in multiple differential backups, this approach requires more storage over time. Differential backups are not used by Azure Backup. If you've worked with Azure Backup before, you may have noticed that the management experience has changed quite a bit since when I created my original videos. You may still find references in the documentation to Azure Backup Center. In many cases, Microsoft now directs administrators toward Azure Business Continuity Center. From there, you'll be taken to Azure Resiliency, which is simply called Resiliency in the Azure portal. Resiliency provides a unified cloud-native management experience for backup, disaster recovery, and protection-related services across your Azure environment. It's also the interface we'll use in the upcoming demo. Now let's get to the question everyone asks: how much does Azure Backup cost? One of the advantages of Azure Backup is its simplicity. There's no separate backup server licensing model, no license bundles to purchase for protected systems, and no storage pool infrastructure to manage. For some workloads, you'll pay for each protected instance in addition to storage costs. Examples of this include Azure Virtual Machines, on-prem virtual machines, SAP HANA instances, and SQL Server workloads. For all protected resources, you'll also pay for the backup storage consumed. So the total cost depends on several factors, including the type of resources being protected, the number of protected instances, the amount of backup data stored, the selected storage redundancy option, and the Azure region where the backup vault resides. Now that we've covered the architecture, protection methods, storage options, security features, and pricing, let's see Azure Backup in action. In the demo, we'll create a Recovery Services Vault, configure a backup policy, and protect an Azure virtual machine. If you'd like to follow along, you'll need access to an Azure VM and sufficient permissions to create and manage Azure Backup Vaults, policies, and protected resources. Let's jump into the Azure portal to get started. Here we are in the Azure portal. This subscription already has an Azure VM to backup. There are a couple of ways we can do this. We could go directly to the VM, then select Backup under Backup and Recovery, and create the backup from there. We also have the option to configure backups during VM deployment. For this demo, we'll configure backups from Resiliency so we can get a better understanding of how backup configuration works across multiple resources. Let's search for an open Resiliency. Next, we'll create the Recovery Services Vault. If you already have a vault available, you can use that. For this example, we'll create a new one. From the Resiliency pane, select Vaults under Backup and Recovery. Then add a new vault. Here are the two vault options we reviewed earlier. Since Azure VMs use the Recovery Services Vault, we'll leave that selected and click Continue. Select the appropriate subscription and resource group. Enter a name for the vault. For this example, I'll use Backup Demo. Then select the location. This needs to be the same region as the VM we're protecting. Next, go to Redundancy. By default, geo-redundant storage is selected. The next option allows us to enable cross-region restore. When that's enabled, we can restore the VM to a different region if needed. If we choose LRS or ZRS, cross-region restore isn't available because the backup data remains within the same region. For this example, we'll use LRS. Now let's go to encryption. We can choose either Microsoft Managed Keys or Customer Managed Keys. We'll leave this set to Microsoft Managed Keys. Next, go to Vault Properties. Here we have the option to make the vault immutable, which prevents backup data from being modified. We can also lock that setting to make it permanent after the vault is created. For this example, we'll leave that option unchecked. After that, we have the soft delete retention period. With soft delete, backup data that's been either accidentally or maliciously deleted can be recovered during the retention period. 14 days is the default setting and the minimum retention period for production workloads. And we can go up to 180 days. One thing to keep in mind, we won't be able to fully remove test or demo vaults until the soft delete retention period expires. There's no charge for the first 14 days, but additional retention beyond 14 days does incur a cost. Select Next to continue to networking. If needed, we can configure private endpoints. For this example, we'll leave it set to public access. Next, go to Tags and add tags as needed. Then select Review and Create. If everything looks correct, click Create. That starts the Recovery Services Vault deployment. The video will pause here until it's finished. Now the deployment is complete, let's go back to Resiliency and open Vaults. And there's our vault. Next, we'll create a new protection policy. From Resiliency, select Protection Policies under Backup and Recovery. This example has some default policies available already, but for this example, we'll create a new backup policy. Select the resource type to protect, Azure VM for this example. Next, select a vault. Since we're protecting an Azure VM, the available option is a Recovery Services Vault. We'll select the vault we created earlier and continue to the next step. We can choose either the standard or enhanced policy type. The difference between the two is outlined on the screen. For this example, we'll use the newer enhanced policy. Enter a name for the policy, backup demo policy for this example. From here, we can configure the backup frequency. With an hourly schedule, we can choose backup intervals of 4, 6, 8, or 12 hours. We can also define a protection window ranging from 4 to 24 hours. This will determine how many backups you create a day. For example, running a backup every 4 hours across a 24-hour period results in 6 backups per day. If we use a 12-hour interval, the result will be 3 backups per day. We can also select the time zone for the schedule. The next option is Instant Restore. When a backup runs, Azure first creates a snapshot, and then the snapshot is copied to a vault. Restoring from the snapshot is faster than restoring from the storage vault. This setting allows us to retain those snapshots for a specified number of days. The number of days available for snapshot retention depends on the backup schedule and duration. Generally, less frequent backups allows for longer snapshot retention. For example, with a backup taking place every 4 hours with a duration of 24 hours, we can have up to 11 days of snapshot retention. If we change the duration to 12 hours, now we have a maximum snapshot retention of 17 days. For this example, we'll set the schedule to every 4 hours, the duration to 24 hours, and retain snapshots for 7 days. Next, we'll configure the retention range for the vault data. We can set the retention based on daily, weekly, monthly, or yearly backups. The values we choose here should align with our organization's backup retention requirements. For this example, we'll retain backup data for 30 days. If we enable weekly backups, we can choose which day to retain and how long to keep those backups. We have similar configuration options for monthly and yearly backups. And again, for this example, we'll only retain daily backups and leave tiering and consistency type disabled. The snapshots are stored in a separate resource group that's created automatically by the backup service. The default naming format is Azure Backup RBAC followed by the region and a unique number. If needed, we can customize the name. Let's leave that blank and select Create. And that creates the protection policy. Now that we have both the vault and the protection policy in place, we can protect the VM. From Resiliency, select Protectable Resources. Select the VM we want to protect. This takes us to the VM. Select Backups under Backup and Disaster Recovery. Now we can use the existing Recovery Services Vault and Protection Policy. Select the subscription and then choose the vault we created earlier. Leave the policy subtype set to Enhanced, and then select the policy we just created. Under Policy Details, we can see the backup frequency and the retention settings. This VM only has one disk, so we'll leave that selected. There is an option also to include disks if we add them in the future. Once everything is configured, select Enable Backup to turn on backup protection for the VM. That starts the deployment, and again, this process will take a moment to complete. We'll pause the video and come back once it's done. Once backup protection has been enabled, we'll go to Resiliency and check the status. Under Backup and Recovery, select Protected Items. The VM we just added shows the status of pending protection. It'll remain in that state until the scheduled backup runs. We can start the backup immediately by selecting View Details from the three-dot menu on the right. This opens the Protected Item Details page. From here, select Backup Now to start a backup job. Adjust the retention date as needed and then select OK. That starts the backup job. We can now monitor its progress by returning to Resiliency. Select Jobs under Backup and Recovery. From here, we can view the status of our backup jobs. This shows backup protection was configured on the VM and the backup job is currently in progress. This process will take some time to complete. As shown on the screen, one of the previous backups for a similar server took over 40 minutes. And that's how you create a Recovery Services Vault, configure a backup policy, and protect an Azure virtual machine using Azure Backup. I hope you found this overview helpful, and it gives you a solid foundation for understanding Azure Backup architecture and workload protection. If you've enjoyed this video, please give it a thumbs up, subscribe to the channel, and share it with others who are learning Azure. Thanks for watching, and I'll see you in the next one.